important to understand how carbohydrates differ one from another to understand how they impact the structure and taste of food and ultimately our health. So the first step in studying carbohydrates is learning the methods for classifying them. Unfortunately, there are many terms and it can lead to confusion. We're going to look at the two most broadly used methods for classifying carbohydrates and how they relate to each other. Now, the first method is using chemical terminology. This is the clearest one if you know the molecular structure of the carbohydrate. That's a big if, but we're going to start there. The smallest chemical unit considered a carbohydrate is called a sugar. And when a carbohydrate composes of a single sugar unit, it's called a monosaccharide. Which just means one sugar unit. There are three common monosaccharides. There's fructose, there's glucose, and there's galactose. Fructose would be commonly found in fruit. Glucose is also found in fruits and some vegetables, but probably the cleanest example of where you get glucose is corn syrup. Corn syrup is composed naturally of 100% glucose. Galactose is not commonly found in food by itself. The next category of carbohydrates using chemical terminology is disaccharides. Disaccharides are composed of two monosaccharides, so two sugar units, that are chemically linked together. For example, we have sucrose. Sucrose is formed by taking a glucose and a fructose molecule together and chemically link them together to be a distinct molecule. There are three common disaccharides, the sucrose, another is the maltose, and then lactose. Sucrose is just a fancy name for table sugar. Maltose is not commonly found in food, and then lactose is found in milk. And that's in cow's milk, human milks, all milk made by mammals. It comes from the same root word as lactating. Now, the last category of carbohydrates using chemical terminology is polysaccharide. And that just stands for many sugar units. It's interesting to note that the sugar units making up these large molecules are all glucose. When we look at that, each one of those units is a glucose molecule. But how they are linked together is what makes one from the other. There are three major polysaccharides: the starch, the fiber, and then glycogen. If we look at the starch, starch is found in foods such as breads and rice, potatoes, legumes, beans, and our body is able to chemically break down each one of those, so we end up those single glucose molecules and then can absorb it. If we look at fiber, it also is made of single units linked together of glucose, but in this instance we cannot break it down. And so we're going to take it from that small intestines and it will pass into that large intestines. And we would find that again in plants. We're going to find it in the structural part of plants, so the fruits and the vegetables and the whole grains and legumes are going to be rich in both starch and fiber. The starch can be broken down to those glucose molecules and absorbed. The fiber can't be. The last category then is glycogen. Glycogen is not found in our foods, but it is found on our body. And we're going to find it specifically in our liver and in our muscles. So we actually consume starch and fiber, but we have glycogen on our bodies. Knowing the chemical structure of carbohydrate provides clues to how it impacts foods and health. Generally, those mono and disaccharides, these groups here, tend to be sweet, and polysaccharides are not. Although lactose is an exception. It's a disaccharide, but not sweet. And if the carbohydrate is digested, such as those mono and disaccharides and the starches, it provides 4 calories per gram. So it's helpful to know the chemical structure and the corresponding chemical terminology for classifying carbohydrates. However, most people do not know the chemical structure of the carbohydrates they eat. The more common terms used for classifying carbohydrates is common terminology are going to be simple and complex carbohydrates. And pretty much, if it's a mono and disaccharide, it is going to be a simple carbohydrate. And if it is a polysaccharide, which those starch and fibers are found in our foods, they're going to be complex carbohydrate. It would be nice if we could just stop there. But the problem is too often with those simple carbohydrates, they're collectively called sugars. And it is common to believe that all sugars are unhealthy, yet no one believes that fruits and milk, which we find here, fruits and our milk, which we find from the simple mono and disaccharides, are unhealthy. So we have to subdivide it into further categories, and we divide it into the two categories of added sugar and naturally occurring sugar. So sugar made by the food itself is considered naturally occurring. So we think about the lactose in milk, and you think about that fructose in the fruits and some vegetables like tomatoes. But and then if you add it to food, such as making in soda pop, that would be considered added sugar. Now, it's interesting to note, however, that you can have the same molecule can be considered a naturally occurring in one food, but considered an added sugar in another. For example, here we have that lactose in milk, and it's a naturally occurring sugar. But we would also see lactose is over here on the list of added sugars. And the difference is if you take that lactose out of milk and you put it into its own little pile, which we can do, and then you add it to another food like bread, which is common to do, it's now considered an added sugar. So defining added sugar sometimes can be confusing. The Food and Drug Administration, which has the jurisdiction over nutrition food labels, defines added sugars as sugar added during the processing of the food or are packaged as such, which includes sugars, those free and monodisaccharides, sugars from syrups such as honey, which some people are sometimes surprised to find that it's an added sugar, and also from the concentrated fruits and vegetables if it's added in levels that are higher than expected naturally. Although current nutrition food labels do not distinguish between added and naturally occurring sugars, future nutrition food labels will be required to provide that information. So, chemical terminology is one method for categorizing carbohydrate, and then we have the more common terminology. When studying carbohydrates, it's important to know how these two methods for classifying carbohydrates work and how they relate each to the other.